All right, let's dive into vanilla.
Vanilla.
Vanilla, yeah. It's a world that's more complex than you might think.
It really is.
So get ready to uncover the chemistry behind that aroma and taste.
That warm, sweet.
Warm and sweet.
Yeah, we all know and love it.
We all know and love it.
Yeah.
So most people, right, they experience vanilla their entire lives.
You do.
But have no idea about the science that goes into creating it.
It's fascinating how little people know about something so ubiquitous.
Exactly. We take it for granted.
We really do.
So to kick things off, let's talk about vanillin.
Okay.
It's the kind of the star molecule of vanilla.
Right.
But what is it? What is it exactly, and how does it work?
Well, vanillin is an organic compound
Okay.
that's found in vanilla beans. And it's really the chemical structure of this compound that gives a vanilla that characteristic warmth and sweetness.
Got it.
It's like a fingerprint.
Okay.
It makes vanilla, unique and recognizable.
Right, but I think one of the sources mentioned that vanilla's aroma
Yeah.
isn't just from vanillin alone.
You're absolutely
There's a whole symphony of other compounds at play.
It's true. It's like an orchestra where vanilla is the lead violin, but then you have other aroma compounds that are playing these supporting roles.
I see.
To create a richer and more nuanced flavor profile.
So I'm picturing like this whole ensemble of tiny molecules all working together.
Working together.
What are some of the other players in this vanilla orchestra?
Well, the specific compounds, they can vary depending on the type of vanilla bean, where it's grown, and how it's cured.
Okay.
But some of the common supporting players include things like guaiacol, which has a smoky, spicy note.
Interesting.
And then there's 4-hydroxybenzaldehyde, which adds a slightly floral, sweet aroma.
Okay.
And then there are just dozens of other
really
minor compounds, each contributing a little something.
Wow.
To the overall complexity.
So it's not just about vanilla.
It's not just vanilla.
It's this whole team.
It's a whole team.
Of molecules.
Yes.
Creating the vanilla experience.
That's right.
Speaking of which, the curing process.
Yes.
Seems super important.
Yes, very.
What actually happens to those vanilla beans during curing?
That's where things get really interesting.
Okay.
Freshly harvested, vanilla beans don't actually have much flavor.
Oh, wow.
The curing process triggers a series of chemical changes that develop those complex aromas.
So how do they transform? How do those bland vanilla beans transform into the flavorful ones that we use?
Well, when vanilla beans are first harvested, they contain a compound called glucovanillin.
Glucovanillin.
Which is essentially vanillin bound to a sugar molecule.
Okay.
And it doesn't have much aroma on its own.
So it's like the flavor's locked away.
Yeah, it's kind of locked away.
How do we unlock it?
Well, during the curing process.
Okay.
The beans go through a carefully controlled sequence of steps.
Okay.
Killing the bean, sweating, drying, and conditioning.
Wow, so they go through a lot.
They do. It's quite a process, and these steps trigger enzymatic reactions that break down the glucovanillin and release that free vanillin, along with those other supporting aroma compounds.
So these enzymes are like tiny chefs.
Like little chefs.
Unlocking the flavor potential within the bean.
It's really quite fascinating.
It's amazing how natural processes are used to create something so delicious.
I know. It's a beautiful example of how we harness these natural biological processes to create something we enjoy.
Exactly. And what's even more fascinating is that, like, slight variations in the curing process.
Oh, absolutely.
Like temperature, humidity, duration.
Yeah, all of that.
Can lead to very different flavor profiles in the final product.
Exactly. It's like fine-tuning a recipe to get that perfect flavor.
Now, you mentioned the final product, vanilla extract.
Yes.
I've always wondered, what exactly is vanilla extract?
Right.
Like, how does it capture all those amazing flavors?
Well, vanilla extract is essentially a concentrated solution of all those lovely vanilla aroma compounds.
Okay.
It's made by soaking cured vanilla beans in alcohol.
Interesting.
Typically ethanol.
So the alcohol acts like a solvent.
It does, yeah.
Pulling out all those different flavors.
It pulls out the whole symphony of flavors that we talked about.
Wow.
Not just the vanilla.
Okay.
That's why real vanilla extract is so much more complex and nuanced than just using synthetic vanillin.
Which brings us to synthetic vanillin.
Yes.
One of our sources mentioned that a lot of the vanilla flavoring we encounter isn't actually from beans at all.
A lot of it isn't, yeah.
Right.
Yeah.
So how is it made?
Well, It's more common than you might think.
Okay.
Synthetic vanillin can be produced from various starting materials.
Okay.
Including lignin, which is a byproduct of the paper industry.
Interesting.
And guaiacol, which is one of those supporting aroma molecules we talked about.
Okay.
Then they're chemically converted into vanillin through a series of reactions.
So it's like they're recreating this molecule from scratch.
Yeah.
Without using
any actual vanilla beans. Yeah.
That's wild.
It is pretty amazing.
So that's why it's so widely used.
Exactly.
Because it's cheaper.
It's significantly cheaper to produce than extracting it from the natural vanilla beans.
So for like large-scale food production,
yeah,
where cost is a factor,
huge factor,
that makes a huge difference.
That makes a huge difference.
This is all so fascinating.
It is fascinating.
It's like vanilla has this secret life we never knew about.
I know, it's pretty cool.
You've really opened my eyes to how much goes into something that we often take for granted.
Well, I'm glad to hear that.
Yeah.
It's a perfect example of how something so familiar can have incredible depth and complexity.
And we've only just scratched the surface.
I
can't wait to dive deeper.
Yeah, it is amazing how much there is to discover about vanilla.
I know. It's pretty amazing.
Before we move on, I'm kind of curious to hear what stood out to you most from our conversation so far.
Honestly, the whole idea of vanilla beans starting out flavorless blew my mind.
I know. It's crazy.
They have the hidden potential.
They do.
That only gets unlocked through this curing process.
Exactly.
It's fascinating.
It is.
And those tiny enzymes acting like chefs.
Like little chefs.
Orchestrating the whole flavor transformation.
It's really incredible.
It's incredible.
It is a testament to the power of natural processes.
I know.
But now that we've explored the intricacies of natural vanilla, I think it's time to delve a bit deeper into its synthetic counterpart.
Yes. Synthetic vanillin.
Synthetic vanillin.
It's fascinating.
Cotton's interesting.
That we can recreate this complex molecule in a lab.
Yeah.
But how does it actually compare to the real deal?
That's a great question.
Like in terms of taste and aroma?
That's a question that often sparks debate.
Really?
While synthetic vanillin is chemically identical to the vanillin found in vanilla beans, it doesn't quite capture that full depth and complexity of natural vanilla extract.
So even though they're the same molecule, the experience is different.
It can be, yeah.
I'm curious, why is that?
Well, remember that symphony of aroma compounds we talked about earlier?
Yes.
Well, synthetic vanillin is typically just pure vanillin.
Okay.
It's like playing a single note on a piano versus hearing a full orchestra.
Gotcha.
You're missing the richness and nuance of all those supporting players.
Now, I understand why those imitation vanilla flavorings never quite taste the same. It's like they're missing something.
Exactly. And it's not just a matter of personal preference.
Really?
Many professional chefs and food scientists can actually distinguish between natural and synthetic vanilla in blind taste tests.
So there's a real difference in quality.
Yeah.
And complexity of the flavor.
Absolutely.
But of course, cost plays a big role.
Cost is a huge factor
in widespread use of synthetic vanillin.
Right. As we mentioned earlier, natural vanilla is one of the most expensive spices in the world.
Wow.
The cultivation and curing processes are very labor-intensive, which drives up the price.
Right.
Synthetic vanillin, on the other hand, can be produced much more cheaply and efficiently.
It seems like a classic case of economics.
Yeah.
Influencing our food choices.
Unfortunately, it often does.
But are there any downsides to this reliance on synthetic vanilla?
Well,
I mean, besides the difference in flavor.
There's a growing awareness of the ethical and sustainability concerns surrounding the vanilla industry.
I see.
The high demand for natural vanilla has unfortunately led to some unsustainable farming practices in certain regions.
That's terrible.
Including deforestation and exploitative labor practices.
That's really disheartening to hear.
Yeah, it's definitely a concern.
But wouldn't switching to synthetic vanilla help alleviate those problems?
It's not as straightforward as it might seem. While using synthetic vanilla could potentially reduce the pressure on natural vanilla production. There's a risk that it could also inadvertently harm the livelihoods of farmers who rely on sustainable vanilla farming practices.
If the demand drops for the natural vanilla, it could lead to a decline in the sustainable farming, which would be counterproductive.
It's a complex issue with no easy answers.
I see.
It highlights the interconnectedness of our food system and the importance of considering the broader impact of our choices.
This deep dive is really making me rethink how I view
Yeah.
Something as seemingly simple
I know.
as vanilla.
It really is fascinating.
It's incredible how something so familiar can have such depth and complexity.
Absolutely.
And we've only just begun to explore its potential.
You're right. There's still so much more to uncover.
I can't wait.
Are you ready to explore some of the cutting-edge research on vanilla?
Yes.
And what the future holds
Absolutely.
for this beloved flavor?
I'm all ears. It's amazing to think about all the possibilities that lie ahead for vanilla.
It really is.
What are some of the exciting developments you're seeing in terms of research and innovation?
Well, one area that's really promising is the development of more sustainable cultivation methods.
Okay.
Researchers are exploring techniques like agroforestry and hydroponics to grow vanilla in a way that's both environmentally friendly and economically viable for farmers.
So it's about finding ways to produce vanilla that's good for the planet and good for the people who grow it.
Exactly.
That's a win-win.
That's the goal.
And on the flavor front,
Yeah.
there's a growing movement towards appreciating the diversity of vanilla varieties.
That's right.
We often think of vanilla as a single flavor,
Right.
but there are actually countless varieties.
There are.
With unique flavor profiles.
It's true.
Oh, that's interesting.
Yeah.
I'm so used to the typical vanilla extract you find at the grocery store.
Right.
What are some of the other varieties out there?
Well, you have Tahitian vanilla, which has these beautiful fruity and floral notes.
Interesting.
And Mexican vanilla, known for its spicy, woody character.
Okay.
And then there are so many lesser-known varieties with their own unique nuances.
Wow.
It's like a whole world of vanilla waiting to be explored.
It sounds like vanilla is having its own craft movement.
Yeah.
Kind of like we've seen with coffee and chocolate.
You hit the nail on the head.
And with this growing appreciation for variety comes a renewed interest in the science behind vanilla's flavor.
Absolutely.
Scientists are using advanced analytical techniques to identify and characterize all the minor compounds that contribute to the overall flavor profile of each variety.
Exactly.
So they're going beyond just vanillin.
They are.
And looking at the entire symphony of flavors.
The whole symphony.
As we talked about earlier.
Right.
And this deeper understanding could lead to some really exciting possibilities.
For sure.
Imagine being able to tailor the flavor of vanilla extract by adjusting the concentrations of specific aroma compounds.
It's amazing to think about.
Or even creating entirely new vanilla flavor profiles by blending extracts from different varieties.
Wow.
That would be revolutionary.
It would.
It's like the potential for vanilla is just beginning to unfold.
I agree.
What other areas of research have you particularly excited?
I'm personally fascinated by the ongoing research into vanilla's potential health benefits.
Oh, okay.
Beyond its delicious flavor and potential mood-boosting effects, scientists are investigating its antioxidant and anti-inflammatory properties.
Interesting.
There's even some early research suggesting that vanilla might have neuroprotective effects.
Wow.
Potentially playing a role in preventing cognitive decline.
I had no idea.
Yeah, it's really interesting.
It's amazing to think that something as simple and enjoyable as vanilla could have such profound implications for our health and well-being.
It's really quite remarkable.
It is.
And that's what makes exploring the science of food so captivating.
Yeah.
There's always more to discover.
Right.
And even the most familiar ingredients can hold surprising secrets waiting to be uncovered.
This deep dive has been an eye-opening experience.
I'm glad to hear that.
I feel like I've gained a whole new appreciation for vanilla.
Well, that's what we hope for with every deep dive.
Yeah.
To spark curiosity and inspire a deeper understanding of the world around us.
So the next time I encounter vanilla, I'll definitely be thinking about the intricate chemistry.
Absolutely.
The diverse flavors and the potential health benefits.
Yeah.
It's more than just a simple flavor. It's a fascinating and multifaceted gem.
Well said. And until next time, keep exploring, keep questioning, and keep diving deep.